Hello, this is Ms. DB, and today we are going to talk about Chapter 5, Section 7 on solving quadratic inequalities. So before we begin, I want to remind you about solving linear inequalities, such as y is less than 2x plus 1. If you were going to graph this, you would graph it just as if you had the equation, instead of an inequality, an equal sign there, which would be, grab my pen here, y equals 2x plus 1. And you could graph that using graphing technology like Desmos or Sketchpad or your graphing calculator, or you could say, well, that's in slope-intercept form, so I'd put a point at 1, and the slope is up 2 over 1, and then I would draw a line between those 2 points. And when I draw my line, now I have to think about what does less than mean. Less than is going to be dashed line, and if it was less than or equal to, then I would have a solid line. So I need a dashed line between those 2 points, and then I shade below the points because I want all the values that would create so that you would have a true inequality. So if I put in here the point 0, 0, which is in my shaded region, if I put 0 in for y and 0 in for x, I test it, it's a test point, and I would get 0 is less than 2 times 0 is 0, is less than 1, which is true. So that means I would shade that region that included the 0, 0, or that I shaded correctly. Generally speaking, if the y is on the left side by itself, then less than means shade below, and greater would mean shade above. And if it's less than or greater than, you use a dashed line. And if it's if it had been less than or equal or greater than or equal, then you would use a solid line. So some of those same skills will be used in this lesson today. So objectives are to solve quadratic inequalities by using tables and graphs, and also to solve them using algebra. When does this happen? This happens with business. Business profits can be modeled by a quadratic function. To ensure that the profit is above a certain level, financial planners may need to graph and solve quadratic inequalities. A quadratic inequality in 2 variables can be written in one of the following forms, where a, b, and c are real numbers. And its solution set is a set of ordered pairs x, y. And here's the possible ways you could write it. So we might have y is less than the quadratic ax squared plus bx plus c, or maybe we'll have y is greater than ax squared plus bx plus c, or perhaps y is less than or equal to ax squared, or perhaps y is greater than or equal. So this is going to be similar to as our linear inequalities that we just reviewed. Here's our steps. First, we're going to go ahead and graph the parabola that defines the boundary. We'll use a solid line for our parabola, for our graph, if it's less than or equal or greater than or equal, and we'll dash that line if it's less than or greater than. We'll shade above for greater than or equal. We'll shade below for less than or equal or less than. So very similar to linear. All right, let's look at an example. Here we have y is greater than or equal to x squared minus 7x plus 10. Now, we can graph these by hand using some of the techniques we learned at the beginning of this chapter. We can find the vertex, we can find the y-intercept, we can find some of the zeros, the x-intercepts. And how did we do that? Let's see. Remember that the y-intercept is going to be the c at the end of the constant at the end of your quadratic equation. To find the vertex, we plug in. First, we find the x-coordinate by going negative b over 2a. So this is a is 1, b is negative 7, and c is 10. So negative b would be negative 7, that would be 7, over 2 times 1. So our x-coordinate of our intercept is 3.5. And then to find the y-coordinate, you plug 3.5 in to your original equation. And you solve this, and you can use your calculator and double check, but we would get negative 2.25. So the vertex right here is at 3.5, negative 2.25. And then our y-intercept is at 10, because that's what c is equal to. And then you can, I wonder if this factors. This does factor. This would factor to be x minus 5, x minus 2, because negative 5 times negative 2 is a plus 10, and negative 5 minus 2, that middle term is going to work to be negative 7. So you're using a lot of the skills that we have used throughout this chapter, and we'll find that the zeros are at 5 and at 2. And then from those points, that helps you graph your parabola if you're doing it by hand. Now, of course, we have Sketchpad and Desmos that can graph this very quickly, and we'll look at that in a minute. Okay, once you have this graphed, either by hand or using technology, then I forgot to double check that I'm supposed to use a solid line, but I am, because it's greater than or equal to, so the solid line was correct. Otherwise, you would try to graph, like, as you make your parabola, you'd try to dash your line, which would be a little tricky with making a curved line or a curved graph. All right, the next thing to do then is to shade. This is y is greater than or equal to this. So when we do our shading, we will shade above that curve. So it looks like it's inside the curve, but it's really above the curve and kind of holding it. And then we will check. So let me go back. You want to check a point that's where you think is inside the shaded region. So they picked 4, 0. You could also pick a point 0, 0 that's outside the shaded region, and then you could make sure that it doesn't work. But they picked 4, 0, which was inside the shaded region, and they want to make sure it works. So you replace y with 0, and you replace x with 4, and you just simplify. So this would be 16 minus 28 plus 10. And if 0 is greater than that, then this works. So we'd have 16 minus 28 is negative 12, plus 10 is negative 2. So 0 is greater than negative 2. So it works, so we shaded the correct region. And like I said, you could use 0, 0, which was outside the shaded region, and this should not work. And 0 is not greater than 10, so this does not work, which means we should not have shaded 0, 0, and we hadn't, so that's good too. Okay, here's another example. This one we're going to solve, instead of doing all the steps by hand, finding the vertex, finding the intercepts, and so on, let's go ahead and graph at Desmos.com. So I'm just going to write this inequality down so that when I go there I don't have to flip back. So y is greater than or equal to 2x squared minus 5x minus 2. Desmos works better than Sketchpad for this type of a graph, an inequality, because it can handle the shaded or not shaded, or I mean dashed or not dashed, and it also does the shading for us. So my inequality I had written down is y is greater than or equal, pick that out of your table here, to 2x squared minus 5x minus 2. And we see that it has shaded the correct amount, the correct part above it. It has used a solid line. If we needed to check the intercepts, it actually graphed them for us, 2.851 and negative 0.351 approximately. It even put the y-intercept on here for us and the vertex. So lots of information was given to us by this quick inequality graphing on Desmos. So if you were going to do it this way for your homework, then you need to take a snip. If you don't have a snipping tool, or if you're not using Microsoft, I think this is a Microsoft thing. Let me get this. So I'm going to take, did I get a snip? Yeah. I'm not sure if I can do it while I'm making a video. Oh yeah, sure I can. So I took a picture of the graph. If you wanted to, you could have dragged it farther to the left so it included the inequality. And now I'm going to copy that copy. And now go to the worksheet, except that well, maybe I will. Is this my worksheet? Here's my worksheet, your worksheet. So I would go to this wasn't actually on your problem. Let's say this was number 1. Then instead of graphing it by hand here, you could just paste in the graph that you found. This was not actually number 1. This was an example in the textbook or in the book. And then that way you have your graph here and it's good to go. All right, I have to go back to my lesson here. And it matches the graph they made. It's a little bit more accurate because we weren't graphing by hand. Oh, and then we check. And they checked at the point 2, 0, which is right here inside the shaded region. And when they tried 2, 0, they found that it did indeed work because 0 is greater than -4, so that means we shaded the correct part. Here's another example. Y is less than -3x squared minus 6x minus 7. Again, you could, this time it's less than, so it'll be a dashed line. You can graph this at Desmos again, and because it's less than, we will shade less than the parabola. So this time we will shade underneath, which ends up being inside. And then we verify with the test point. I want to look at, there's another example with, oh no, there's not. Okay, so these are the ones that are on your worksheet. I would definitely use Desmos for this. Let's do number 4 looks hard, although it's really not using Desmos. So number 4 says y is greater than 2x squared minus x minus 7. So I'm going to go back to Desmos, and in order to not get out of the lesson, I'm just going to go back to where I had the link. There it is. Okay, so this time I am going to go to a graph y is greater than 2x squared minus x and then minus 7. So this time it's a dashed line, and we shaded above because it's greater than. If you can't see as much as you want before you take your screenshot, you can zoom out over here. This one did not automatically add my points, but you can click and your points will, there's the y-intercept at -7, and here's the vertex, and here is the one of the zeros, and here's the other 0 if you're asked to fill that in. And then you can take your screenshot or your snip and put it on there. All right, back to my video. So this example we had already done, and then I was doing number 4 from your worksheet. And then I would take a screenshot or a snip and put it in there. So for 1 and 2, you have to say whether your line, what the vertex is, whether your line is dashed or solid, and what the y-intercept is. And then use your test point. On 3 and 4, you can just add the graphs. So there's a little bit more things to write for 1 and 2. You can write those as well for 3 and 4 if you want to, but you don't have to. All right, now we're going to look at quadratic inequalities that instead of having y is greater than this, they're going to have a number there. So here's an example. X squared plus 8x plus 20 is greater than or equal to 5. We do this a little bit differently than the last example where it was y is greater than or equal to a quadratic inequality. So what we do is we write this as 2 separate equations. One of our equations will be y is equal to x squared plus 8x plus 20, and the other one will be y is equal to 5. And then we're going to look at when the first equation is greater than the second equation, in this case, because it's greater than or equal to. So we do graph it. We graph both of those at the same time. And when we graph it on a graphing calculator, it looks like this over here. So we graph the parabola x squared plus 8x plus 20, and it gives you this curved line, and we graph x equals 5, and it looks like, or y equals 5, and it looks like this. So the answer to this would be whenever the parabola, the x squared plus 8x plus 20, is above the line x equals 5. And that happens at less than whatever this number is, -1, -2, -3, -4, -5. So whenever x is less than -5, it works. And whenever x is greater than -3, it worked. So therefore, we have to write an inequality for our answer. We write that x is less than or equal to -5, or x can be greater than or equal to -3. You can also write it using this notation that we learned in Chapter 1. If you want, either one is completely fine. You can also graph it on a number line. It's a little bit harder to graph on a number line using a Word document, so you don't have to show the number line solution for your worksheet. You can just show the graph, or the x is less than or equal to -5, or this is an or, not an and, because the points in between there would not work. Okay, here's another example. This is from your worksheet. This is number 6 from your worksheet. So again, we're going to set this equal to two separate inequalities. Two separate equations. One of your equations is going to be y is equal to x squared minus 9x. The other one is going to be y is equal to -18. So our first step is to graph both of those equations on the same coordinate system, and we'll use Desmos. All right, we could use Sketchpad for this, but Desmos works so nice, and you've already have it open. So x squared minus 9x is our first equation to graph. And I'll zoom out in a minute. And the other one is -18. Y is equal to -18. Now we have to zoom out because I can't see everything that I need to see. So here's my zoom out button. And I can move it up by just clicking and dragging it. So here's my line. I'm going to move over now so you can see my original equations. So the blue line is y is equal to -18. And the red line is y is equal to x squared minus 9x, which is a parabola. Now in my third inequality, which you absolutely do not have to write in this, shoot, I forgot if it was greater than or let's see if I can see it. Greater than. Okay. Oops, I didn't get enough information from that quick glance. So x squared minus 9x is greater than. That's how the original inequality for the problem was. Oops. X squared minus 9x. I'm not going to show this yet. Turn it off. Okay, so what this is what the original inequality was. We wanted to know when is the parabola, the x squared minus 9x, the red line, greater than the blue line. So it's greater than all this way. See, it's above it, all the way to here. Then we stop because it's less than below the line here. So we don't want to include those points. And then we go back to greater than. So it works for the numbers less than whatever this number here is. 3. When x is less than 3, it worked. And it also works for all of the x values greater than 6, because all the x values greater than 6 would be on this side. Now, if I do type this into Desmos, the whole thing with the inequality in both sides, then you will see the shading, the green shading, is the solution area. So it's when x is less than 3, not equal to, because they're dash lines, because it's greater than, not greater than or equal. So when x is less than 3, or when x is greater than 6. When x is less than 3, or greater than 6. So the solution set, the answer that you would write is x is less than 3 or x is greater than 6, because the values in that region work. You can also show that on a number line. So we'd have the numbers less than 3 and greater than 6. These are called critical values. The 3 and the 6 that we just found, those are critical values. That's where, either less than or greater than is going to either work or not work at those points. And by finding those, we can solve algebraically. So here's how we solve a quadratic equation by using algebra instead of graphing. Here is our problem. X squared minus 10x plus 18 is less than or equal to negative 3. So we start by writing this as an equation. So I take away the inequality and I turn it into an equation with an equal sign. And now we're going to solve that equation. So my original, I'm going to go back a step. I start by adding 3 to both sides. So we add 3, add 3. So we would get x squared minus 10x plus 21 equals 0. And you've done problems like this before now. We are going to check and see if it factors. That's one way we could solve this quadratic equation. If it doesn't factor, we could complete the square, or we could use the quadratic formula. However, all of the ones on your worksheet will be factorable, so you can use factoring to solve each of these. Now remember, when you factor, you are looking at the last term, which is 21, and you want to find the factors of 21, something times something, that when you add them together, you will get a negative 10. So 3 plus 7 does not equal negative 10. But negative 3 times negative 7, or plus negative 7, does equal negative 10. So those are the factors I want to use. So you rewrite this as x minus 3, x minus 7 equals 0. I can erase mine because they have the exact same thing. And then we have 2 mini equations to solve, and you set them both equal to 0. So x minus 3 equals 0, or x minus 7 equals 0. And then you solve those little equations by, I'll add 3 to both sides. So x equals 3 or x equals 7. So I have these are my critical values. Now what does that mean? That means that at 3 and 7, that's where those two lines were going to intercept, the parabola and the line. So that means either my solution set either lies less than 3, it lies between the two numbers, or it lies greater than 7. So we're going to have to check now to see where will that solution lie? Where will the parabola match what my original inequality said? So we need to test a point from each of those regions. So I have to pick a number less than 3, I have to pick a number between 3 and 7, and I have to pick a number greater than 7. So let's use the points. X equals 2. These didn't line up correctly. So I have to pick a point less than 3. So ignore this. That would be, they're picking the point. Oh no, 3 and 7 are the critical values. Okay, never mind, that's correct. So I'm going to try 2, 4, and 8. The first one is less than 3, so I plug that in. So x equals 2. So that would be 2 squared is 4, minus 10 times 2 is 20, plus 18. Is that less than or equal to negative 3? 4 minus 20 is negative 16, plus 18 is negative 2. Negative 2 is actually greater than negative 3. It's not less than. So that did not work. Then they tried a point between 3 and 7, and they picked 4. So 4 squared is 16, minus 10 times 4 is 40, plus 18. So 16 minus 40 is negative 24. Negative 24 plus 18 is negative 6, and negative 6 is less than negative 3, so that one worked. And then they tried the point 8, which was on the upper region above 7, and 8 squared is 64 minus 80 plus 18, and that is, let's see, 64 minus 80 is negative 16. plus 18 is 2, and 2 is not less than or equal to negative 3, so that did not work. So the only one that worked was in the middle, which means that my solution is going to be between 3 and 7, and it can include those because these were less than or equal. So your solution is that x is between 3 and 7, or could include it. So you could use those square brackets if you wanted. And you put the 3 on the left and the 7 on the right. So this is your answer. You have to write your answer for your problem. Okay, here's number 8 on the worksheet. We're going to do this the same way. So first thing that we have to do is change this to an equal sign. So that's all we do first. Then we set it equal to 0. So I'm going to subtract 6 from both sides, and I'll get x squared plus x minus 2 equals 0. Now we want to factor this, and it is going to be factorable. So we have to find the factors of negative 2 that will equal a 1 when we add those together. So there's not very many factors of negative 2. It's either negative 1 and 2, or it's negative 2 and 1. Which one of these will add to equal a positive 1? Negative 2 plus 1, that's negative 1. Negative 1 plus 2 is a positive 1. So we want to use these. So my factors are x minus 1 and x plus 2. Next, you set each of those little equations, those factors, equal to 0 and solve those little equations. So x minus 1 equals 0, or x plus 2 equals 0. And then you solve both of those little equations. So in the first one, you would add 1 to both sides, and you'd get x equals 1. In the other one, you'd subtract 2 from both sides, and you'd get x equals negative 2. So our two x values, our critical values, are 1 and negative 2. This is what you'll put for your this is from your worksheet. Okay, so now that we have our critical values, that means that we have 3 regions that we need to check. One of our regions needs to be, I'm going to rewrite this. The smaller number I'm going to write first. And the smaller one is the negative 2. So I'm going to check something less than negative 2. Like I could check negative 3 or negative 4 or negative 5. I'm going to check something between negative 2 and 1. And 0 would be a great one to check. And something greater than 1. Like 2, 3, 4, something like that. So those are the 3 regions that I have to check. So here's my critical values at negative 2 and 1. I'm going to use the points negative 3 for the less than negative 2. I'm going to use 0 for the in between, and I'm going to use 5 for the greater than. Okay, so when we try negative 3, we plug negative 3 in for x. So we'd have negative 3 squared, that's 9. And then I'd have plus negative 3 plus 4. So 9 plus negative 3 is 6. 6 plus 4 is 10. 10 is not less than 6. That did not work. So next I'm going to try 0. So 0 squared is 0 plus 4. That's 4 is less than 6. That works. 4 is less than 6. That's true. And then I try 5. I get 25 plus 5 plus 4. That's 34, which is not less than 6. So that one does not work. So the region that worked was between the critical values. Now this is less than, so when we write this, our solution is between negative 2, so I'll use an open circle at negative 2, and an open circle at 1, and I want all of the values between there, which will be my solution. So you would write it like this in your words. That's your solution, and you can make a number line graph. Now you don't have to add the number line graph for your answers here, but this is what the graph would look like. It would show that you want the values that work in this inequality would be between negative 2 and 1. Another way we could write this, and I should have written it like this, typed it out, would be like this. This also says that x is between negative 2 and 1. That combines both of those inequalities into one compound inequality. Here's number 10 from the worksheet. I'm going to start this one but not finish it. So again, our first step is to replace the inequality with an equal sign, and then we will set this equal to 0. So we will get x squared plus 6x plus 5 equals 0. Then we will factor that. And 5, the factors of 5 that equal 6, so you can either do 1 times 5 or 5 times 1. They're the same thing. They both equal 6. So we write our factors as x plus 5 times x plus 1. Then you set each of those equal to 0. So your two critical values would be x equals -5 and x equals -1. So when you look at what would be the possible region for solutions, you have to look at something less than -5. You have to look at a number between the two of them. And you have to look at something greater than -1. So here's my critical values at -5 and at -1. And my test points, I just picked 3 from the region. You can pick different points. So I picked -6 for my first one. And then I'm going to check -2 for my in between the points. And then I'm going to pick 0 for my greater than. That's the easiest one. And you will find that either 1 or 2 of these regions will work. Now, your regions will either be yes and yes, and the middle one will be a no, or it will go no, yes, no. It's going to be in a pattern like that, because it's either going to be this way and this way that works, or it's going to be between. It's not going to be like this and this. So you'll have to solve these little inequalities and see what your solution region is going to be. It's either going to be less than -5 and greater than -1, or greater than -1, or it'll be x will be between -5 and -1. So you'll check that out, and then you will answer the question whether it is x is greater than something and, that would be if it's in between, or maybe it's going to be an or if it ends up being, less than the first critical value and greater than the other critical value. All right, I hope that helps. Have a wonderful day, and please email me, call me, text me if you have any questions. Thank you very much, and I'll talk to you soon.